To analyze the RE equivalent model for emitter follower circuit and derive the expressions for input impedance, output impedance and voltage gain. So step 1, let me draw the circuit diagram of emitter follower. So name itself indicates that the output is taken across the emitter. Okay. So how will you draw the circuit diagram of emitter follower? So input is going to be your base, collector, and emitter is your output. Okay, so across the base you will be having your resistor RB, collector will be going directly to your VCC, and input you will be having your coupling capacitor C1 where you will be getting it as VI, and across the emitter you are going to take your output. So RE and coupling capacitor C2, and this is your output. Looking from towards your circuit input side, it is your input impedance. Looking from the output towards your circuit is your output impedance, right? So the current here I am taking it as I0 and here it is I, right? So this will be your circuit diagram of your emitter follower. Step 2, I am going to draw the RE model. Okay, RE model of emitter follower. So how will you replace? First you are going to replace the transistor by its equivalent RE model. So how will you replace the transistor? Across the base you will be having beta into RE. Across the collector you have beta IB current source in parallel with that of your output resistance R0, right? So this will be your collector terminal, base terminal. The current flowing through the base is your IB. Right, now across the emitter terminal, here you have to be careful. Across the emitter terminal you have your resistor RE. So before that let me complete this. So you have replaced the transistor now by means of its RE model. Now you are going to add the other components, passive components. So one is your resistor RE. Okay, so the current here will be equal to I0, and across the emitter you are going to take your output voltage, that is V0. Okay, and I think you know the basic preliminary step. When you have to convert it into an RE model, the capacitor should be shorted and VCC must be shorted, right? So from the if VCC is shorted, RB will go directly to the ground. So you have RB, from the base you have RB, and collector also will go directly to the ground. Okay, so since the collector is going directly to the ground, it is also called by another name, common collector configuration, other name of emitter follower. Okay, and in the case of emitter follower, the voltage gain will be approximately equal to 1. Output will be following the input. Oh, these are some of the important terms of your emitter follower. Okay, so now we are going on to the topic. So first we are going to find out what is your input impedance. So looking from the input, so this will be your input Vi. So looking towards your input, the total input impedance is taken as Zi, but here also you have a resistive effect. So here it will, I am taking the impedance as Zb. Zb will be the combination of beta Re and capital Re, but here you know that the current flowing is IE. So for example, for a series combination, if you have in a series combination, you know that the current flowing should be the same current. So here it is IB. Now I have to convert this IE to IB. So how I can convert? IE will be approximately equal to beta plus 1 into IB. So instead of IE, you are going to replace by this. So here instead of IE, I am going to write it as beta plus 1 into IB. Okay, so now I can write Zi is equal to RB parallel to ZB. Now in order to find out ZB, what will be your ZB? ZB will be equal to beta Re plus beta plus 1 into capital Re. So I can write as beta Re plus beta plus 1 into capital Re, right? I hope so till this you are clear. Now compared to 1, beta is very greater than 1. So you can neglect 1. So what you will be getting, ZB will be equal to beta Re plus beta into capital Re. So I can take beta as common, right? So I can write beta Re plus capital Re. Okay. So ZB will be approximately equal to beta Re plus capital Re. But you know that capital Re is normally very greater than small re. So what will be your value? I can approximate that ZB will be approximately equal to beta into capital RE. Under the condition capital RE greater than small re. So what will be your input impedance? Input impedance is equal to RB parallel to ZB. I am writing without the condition. So beta into RE plus RE. This will be your input impedance. Okay, so let us move on to the second value, that is your output impedance. So in order to find out the output impedance, let us start with finding out what is the current IB. You can write current IB is equal to, for your clarity, I'll just draw the diagram once again. So across the input side you will be getting beta RE, right? Across the collector you will be getting beta IB. So for this, in order to simplify the equation, we are neglecting, or we are considering R naught is equal to infinite, and we are omitting R naught now. Without R naught we are going to calculate the value. So this will be your collector. Across the input side base you will be having your resistor RB, right? And looking towards, it will be your input impedance Zi. Across the emitter you are going to take your output, so you will be getting RE, and this will be your output. So this will be your output impedance Z0. Okay, and this will be your Zi from the input side. Okay, the current flowing here is IB. Okay, and here it is IE, and here it is I0. Okay, so in order to find out what is your Z0, you are starting off with IB. IB is equal to, you know that, voltage divided by resistor, VI divided by ZB, right? VI divided by ZB. So multiplying both sides by beta plus 1, because our intention is to find out the emitter current IE. Okay, so if you multiply both sides, I'll get beta plus 1 into IB is equal to beta plus 1 into VI divided by ZB. So now you know that beta plus 1 into IB is equal to IE. So I can write that IE is equal to beta plus 1 into VI divided by ZB. Already you have calculated. What is your ZB? Beta RE plus beta plus 1 into capital RE, right? Same concept which we have seen in the last derivation. Now, since you know that beta is very greater than 1, we are going to neglect 1. So you can write it as beta Vi divided by beta Re into Re plus beta into capital Re. Can we take beta as common? So beta Vi divided by beta into Re plus capital Re. Okay, so I can cancel this. So I am getting IE is equal to Vi divided by Re plus capital Re. So this is my desired equation. Now, so step 1, I have found out what is your IE. So now I am going to construct or reconstruct a diagram with respect to that of this current IE. So I am taking the voltage source as Vi, okay, plus minus, with two resistor, that is Re and resistor capital Re, okay, and the output voltage is V0. So looking towards your, from the output, it is your output impedance, and the current flowing across this is IE, okay, IE. Now, in order to determine the output impedance, what is the same procedure? What you do, you make Vi input is equal to 0. So if I make Vi is equal to 0, you can write directly that Z0 is equal to Re parallel to capital Re, right? So if we take an assumption, you know that capital Re is very greater than small re. Since it is a parallel combination, you can write that Z0 is approximately equal to small re under the condition capital Re greater than is equal to small re. Why we are neglecting? Because it is a parallel combination. We are going to neglect the higher term. Okay, so we are going for the last term, that is your AV. So in order to find out the voltage gain AV, we are going to consider the same figure. Okay, the same figure which we used for output impedance. So what is your AV? AV is, you know that it is output voltage divided by input voltage. Okay, so from this, can you find out what is your output voltage? Apply voltage division rule. So what will be your output voltage? V naught will be equal to input voltage, right, into the voltage across which resistor, capital RE divided by the total resistor, RE plus capital RE. So you will be getting V naught divided by, if I take this VI down, I will be getting RE divided by RE plus capital RE. So what will be your AV? Your voltage gain AV is equal to RE divided by RE plus RE. So when you take an assumption, what is the assumption? Your capital RE is very greater than small re. So you will be getting AV approximately equal to RE divided by capital RE, which will be approximately equal to 1, satisfying the condition. For emitter follower, voltage gain will be equal to 1.